Hello everyone. Today we're going to dive into the exciting world of engineering drawings. Specifically, we're going to learn how to read the technical blueprint for an electrical coil winding machine, a machine used to wrap wire into coils for things like electric motors and transformers. This is a fundamental skill in engineering and manufacturing, and by the end of this lesson, you'll be able to look at a complex drawing and understand what it's telling you. Understanding engineering drawing. So, what exactly is an engineering drawing? Think of it as a universal language, a common way for technical people all over the world to communicate with each other. Just like any other language, it has its own rules and grammar. Engineers, architects, and designers use these drawings to communicate their ideas to manufacturers in order to make the product precisely as designed. A complete engineering drawing isn't just one picture, it's a collection of specific views and information. The key components you will typically find are an exploded view in 3D, a 3D or isometric view, parts drawings in orthographic projections either in first angle or third angle, sectional views, and conventions, symbols and terms. Reading the electrical coil winding machine drawing. Now, we will apply these concepts to read the actual engineering drawing of an electrical coil winding machine. We will look closely at the various components, symbols, views, and terms used on this drawing. This drawing shows the complete assembly. On the right, you can see the component parts aligned ready for assembly, or the exploded view, for the coil winder. This view helps us identify each piece with a letter. From A to J, the drawing specifies that it uses first angle projection and that all dimensions are in millimeters. Part A, end bearing. Let's look at the detailed drawing for Part A, the end bearing. This component has a total height of 85 millimeters. The top edge has a large radius of 17, and there is a through hole with a diameter of 14. The sectional view shows that a bronze bush is pressed into the top hole. At the bottom, there is a blind hole for a threaded bolt, indicated by M8, which means a metric M8 thread. Part B, coil former locking nut. Next is Part B, the coil former locking nut. This is a conical shape. The large end has a diameter of 40 and the body has a length of 45 millimeters. The symbol M10 indicates the internal thread, confirming it screws onto a matching M10 shaft. The small end has a diameter of 15. Part C, coil former. Here we have Part C, the coil former. It's a hollow cylinder with an overall length of 100 millimeters. The outer diameter is 36, and the inner diameter is 30. Part D, spindle. This is Part D, the spindle. It is the main rotating shaft. The main cylindrical section is 185 millimeters long. It has multiple diameters, starting at 8 and including 10. Key threaded sections are indicated by M10, M8, and the very end is threaded M6. Part E, body. Here is Part E, the body. The main base dimension is 235 millimeters long. Notice the curved corners, called fillets, which have a radius of 10. The sectional view, cut along the line YY, clearly shows where the bronze bush is fitted into the top hole, indicated by a large radius of 17. Remaining parts F, G, H, J. The smaller assembly parts include Part F, spindle locking nut, which has an external diameter of 20 and an internal M8 thread. Part G, spindle handle, a piece with a height of 50 and features a radius of 9. Part H, washer, with an outer diameter of 40 and a thickness of 5. And Part J, bolt, an M8 bolt with a length of 25. Review of views and conventions. The full assembly drawing on page 16 shows a section YY and a section XX, revealing internal construction and how the components interact. This helps confirm the placement of the coil former within the body. Remember the conventions used on the drawing. The circle with a line through it indicates diameter. The letter R indicates radius, e.g., R17. M followed by a number, e.g., M8 indicates a metric screw thread. Summary. To summarize, we have discussed the fundamental elements of an engineering drawing. Engineering drawing as a universal language. the importance of conventions, terms, and symbols, how to interpret sectional views and an exploded view, and how to read detailed parts drawings and the dimensions. You have now successfully navigated the technical blueprint for an electrical coil winding machine. The end.